Today we're gonna learn about the behavior of gas. Before we start, let's do a quick review of the last video that might help us in understanding today's lesson. These three models represent the three states of matter. Particles of solid associate are close together. They vibrate in place. The particles of liquid are also close, but they can slide past each other. The particles of gas are far away and move independently. That was a quick review of the characteristic of gas and all the states of matter. Now let's talk about gas in details. When I think about gas, it's easy for me to think about a balloon. The balloon itself isn't a gas, it's a rubber. But inside the balloon are gas molecules. The air we breathe is made of different gas molecules, mostly nitrogen and oxygen, but there are other chemicals like carbon dioxide too. But they don't just sit around. Gases are very energetic, they bounce like crazy. Unlike the particles that make up solid and liquids, gas particles have a large amount of empty space between them. The space that gas particles occupy is the gas's volume, which can change because of temperature and pressure. One of the factors that can affect the gas behavior is temperature. Temperature is the measure of how hot or cold something is, and is the measure of the movement of the particle. It shows how fast the particle is moving. Check this out. This is how temperature affects the gas movement. As the temperature inside the jar decreases, the gas molecules move more slowly. And as the temperature increases, the gas molecules move more quickly. How much helium is needed to fill a parade balloon like this one? The answer depends on the outdoor temperature. On a hot day, the particles of gas are moving faster and hitting the inside walls of the balloon harder. Therefore, the gas is expanding and pushing on the wall of the balloon with a greater force. If the gas expands too much, the balloon will explode. But what will happen if the weather is cool on the day of the parade? Comment your answer. Now about volume. As I mentioned before, the particles have a large amount of empty space between them, and the space they occupy is the volume. So volume is the amount of the space that the gas take. But because the particles of gas are spread out, the volume of any gas depends on the container that the gas is in. Another unique characteristic of gas is that it can be compressed. You can twist and flatten balloons into different shapes. This is only because the particles of gas can be compressed. But if you try to shape a balloon filled up with water, the balloon would probably explode. Why? Because the particles of liquid can be compressed as much as particles of gases. Have you ever wondered why basketball feels harder than a beach ball? The answer is because of pressure. Pressure is the amount of force exerted on a given area of surface. To understand this, let me remind you of the balloon that I talked about in the beginning of this video. Inside the balloon are gas molecules, and they don't just sit around. Gases are very energetic and they bounce like crazy. The molecules bounce into each other without reacting, and they bounce against the wall of the balloon, which exert pressure on the inside of the balloon. So the more gas particles we have, the more pressure we have. As you see in this picture, the basketball has a higher pressure because there are more particles of gas in it, and they are closer together. The beach ball has a lower pressure because there are fewer particles of gas. They are farther apart. Scientists have found that the temperature, pressure, and volume of a gas are linked. Changing one of the factors change the other two factors. The relationship between temperature, pressure, and volume are described by gas laws. Now, we're going to talk about two laws, Boyles Law and Charles' Law. First, we're going to start with Boyles' Law. He described the relationship between volume and pressure when the temperature is fixed. So he realized that the volume of a gas is inversely related to the pressure. As the pressure of a gas increases, the volume decreases by the same amount. We have this model to see how one variable affects another. By using a sealed container in fixed temperature, and just like we said earlier, when we decrease the volume, the pressure increases. So this relationship is an inverse relationship. In a demonstration of Boyles' law, we'll place the balloon in a vacuum bell jar. We will apply a vacuum, which basically pumps out the air in the bell jar, and in this way, the pressure outside of the balloon is decreased. The volume of the gas inside the balloon will increase, and this is what you see here. Once we start to increase the pressure, the balloon will start to get smaller. In other words, the volume will start to get decreased. Now we're gonna try this with a marshmallow. A marshmallow contains air trapped in a mixture of gelatin and sugar. As we apply the vacuum, the pressure is decreased, and then the volume of the air that is inside of the marshmallow is increased. This is why the size of the marshmallow is getting bigger. In another illustration of Boyles' law, we will put some shaving cream into our vacuum jar. The shaving cream contains air trapped in a soap mixture. As we apply the vacuum, the pressure outside is decreased. The volume of the air is increased. So this is Boyles' law. It stated that for a fixed amount of gas at a constant temperature, the volume of the gas is inversely related to pressure. The second law is Charles' law. He described the relationship between volume and temperature when pressure is fixed. He stated that the volume of the gas changes in the same way that the temperature of the gas changes. So if the temperature increases, the volume of gas also increases by the same amount. In like manner, when the temperature decreases, the volume of the gas decreases too. Have you ever tried to put a balloon in a freezer? After a few hours, when you pull it out, you will find a shrunken balloon. As it warms up, it will come back to the full size. So as temperature goes down, volume goes down too. This is a direct relationship, just like how Charles stated. In this demonstration, we're gonna put a balloon inside of a warm water. Here, the temperature is increased, and so the volume of the balloon will increase too. This proves Charles' law. This is another experiment. This time we are going to use a bottle instead of a balloon. First, you have to crush the bottle so that the least amount of air will remain there. Now we're gonna put the bottle in the boiling water. Look at how the air inside of the bottle starts to expand. What is happening here is that the pressure is stable, and as the temperature is increased, the volume of the air inside of the bottle is increased too. Charles' law stated that for a fixed amount of gas at a constant pressure, the volume of the gas changes in the same way the temperature of the gas changes. Here is a summary of today's lesson. Temperature measures how fast the particles in an object are moving. Gas pressure increases as the number of collisions of gas particles increases. Boyles Law stated that the volume of a gas increases or the pressure decreases if the temperature doesn't change. Charles' law stated that the volume of a gas increases or the temperature increases if the pressure doesn't change. That's it for today. Don't forget to answer the question of section review and feel free to ask any question. Have a great day. Goodbye.